Okay, so this video is on the fundamental counting principle and on using tree diagrams. Um, Basically, what both of these things do for us is they help us come up with the number of combinations of what can happen when you're talking about multiple events happening. Goes right along with the probability. So the first one we're going to talk about is a tree diagram. So you can see here in the middle what a tree diagram does for us is it shows all the possible outcomes or combinations of an experiment. Like I said, this usually involves, we use this when we're talking about more than one event occurring. Okay, so I'm going to give you an example here. Let's say a mother has 3 children. We want to know what are all the possible combinations for the genders of the children. So we can figure this out by making what we call a tree diagram. It's called a tree diagram because we make branches out of it. So we know that when you have a child, obviously there are 2 possibilities for the gender. The baby could be male or female. So we start with 2 branches and we label them with M for male and F for female. This represents the choices of what could happen for the first child. So now, to see what happens when you have the second child, you branch off from each of these, because no matter what, if she had a male the first time, the second time she could still have either one, either a male or a female. So I need from here 2 branches and label one with male and one with female. At the same time, if she has a female the first time, she has 2 possibilities the second time. She could either have a male or she could have another female. So when you have 2 children, there are actually 4 possible combinations of males and females. I could have 2 males. I could have a male first and then a female. I could have a female first and then a male. Or I could have 2 females. So there are 4 possibilities when someone has 2 children. Now, if we want to talk about the third child, we got to make branches off each one of these, because no matter what the first 2 are, what combination you're at, you have 2 choices each way. In any of these cases, you could have a male or a female. So off of each of these 4, we need to make 2 more branches. One for male in each, one for female in each. Now, if we're doing something other than children, where there's only 2 choices, like if we were talking about something you had 3 choices, then you would need 3 branches off of each. If you were doing something that had 4 choices, then you would need 4 branches off of each one of these. It's because we only have 2 choices that we only use 2 branches each time. And so if I have 3 children, there are actually 1, 2, 3, 4, 5, 6, 7, 8 different combinations for having males and females. And you can actually use this tree diagram to write out what all those combinations are. From the top one here, I could have 3 males. The second one here comes from having a male, then a female. And so that one would be M, M, and F. This one here, if I follow back the tree, it came from a male first, female second, male third. So that would be an M, then F, then M. This one here, followed back, comes from a male first, then female. And I can fill out the rest of this chart doing the same thing. Female, male, male. Female, male, female. Female, female, male. And all 3 females. And so this helps us, sometimes we get questions like, how many different ways could a mother end up with two boys? Well, I have one up here with two boys in it. I have another one here that shows two boys. I have one here that shows two boys, and that looks like it. So there would be three different ways you could end up with two boys if you have three children. You could also use this for probability. Somebody say, you know, if somebody has three children, what's the probability that they're going to have at least one female, let's say? Well, if you're having at least one female, that means you can have one, two, or all three females. That's a favorable outcome. And so when I look at this, right there, that one's got a female. Yep, yes on that. That's got two, and all three. So 1, 2, 3, 4, 5, 6, 7 favorable outcomes there. And we had counted up before, there was 8 total outcomes. So the probability of having at least one female is pretty good when you have 3 children. It's 7 out of 8 times people will end up with at least one female. You know, and so this is what we use tree diagrams for. It actually shows us what the combinations are so we could then answer questions about those combinations and even probability questions. Okay? Now, the fundamental counting principle, what that does for us, it helps us count the number of combinations, but it doesn't give us any information on what those combinations actually are. So it says, so here is the definition for fundamental counting principle. It says, if one event occurs in m ways, and a second event can occur in n different ways, then the number of ways that the two can occur together is m times n. So in other words, let's say, you know, spring break is coming up here in just a couple of weeks. Let's say that somebody was going on a trip down to Florida, and so they were going to fly out of Buffalo. So they get online, and they see that Atlanta has a very big airport, and a lot of flights go through Atlanta. And so the cheapest way to get down to Florida is to fly through Atlanta. So somebody gets online and they can find, let's say they find 8 different flights that fit their schedule going from Buffalo to Atlanta. And then based on when they get to Atlanta, there are 4 flights that will fit their schedule to get from Atlanta to Florida. So 8 ways you can get from Buffalo to Atlanta, and then 4 ways that you could get from Atlanta down to Florida. That means, by the fundamental counting principle, there would be 8 times 4 ways to get from Buffalo, to fly from Buffalo down to Florida with their schedule. So in other words, they'd have 32 ways to fly down there, which is nice because then they can get on and check all those different flights and pick the ones that fit their schedule the best and are the cheapest. And they have 32 different possibilities they can go through. So the fundamental counting principle, it tells us how many ways we could get there, but it doesn't give us any specific information about those ways. So in other words, if we wanted a specific airline, say, well, I really like Continental, so I want to make sure I'm flying Continental, I can't see with the fundamental counting principle how many ways I can get from Buffalo to Florida using Continental, but I can see the total number of ways. If I want to know just the number of Continental, I either need to figure that out here and use the counting principle, or I need to make a tree diagram and actually show what each flight is. If I wanted to rank my choices of airlines and then pick my flights based on that, I would use a tree diagram so I could see who I'd be flying with in each case and make my decision that way. But they both help us count the ways. The difference is counting principle only gives us the number, and the tree diagram gives us more information.